Now for number 2a, it wants us to sketch the conditions here on a Argand diagram. So I'm going to solve this problem within 3 minutes, and we'll get to question B after. So without further ado, let's start the timer. Okay, 3 minutes is on. So first things first, I'm going to draw my Argand diagram. Boom. 1 minute per mark, remember. Okay, draw the Argand diagram. I'll take that a little bit lower actually. Okay, got imaginary axis over here. We've got the real axis over here. Okay, cool. Now, 1 plus 2i. So remember that this is the same thing as saying 1 plus z minus 1 plus 2i, right? So we've got 1 over here, 2 over here. This is going to be our starting point. And what's the region? Pi over 3 to negative pi over 3. Excuse me. And then the real value of z must be below 3. So 2, 3. We've got 3 here. Okay. So what's it going to look like? Well, we are going to have a situation where we've got a triangle like this. Okay, and we got pi over 3 here, pi over 3 here. Okay, real value z over here. Okay, what does this show us? What are we missing here? Well, complex numbers. Well, that makes sense. It's within the bounds. Negative pi over 3 over here, pi over 3 over here. How much time are we doing? How are we doing for time? We've got loads of time. Yeah, I think that basically makes sense. Sorted. And let me just shade it in to finish it off. Right guys, now it wants us to calculate the least value of argz for points in the region from A. Okay, so up here. Give your answer in radians to correct the 3 decimal places. Okay, so 2 marks, 2 minutes, let's crack on. Right, so least value of argz. What can we see here? Well, when is that? So we know what z is of the arg. So we know what argz is. Okay, so it spans in here. So it's definitely going to be negative pi over 3. Okay, we know that. And where do we kind of go from here? Well, we know, right, that we've got 1 plus 2i, right? And we know that the least value has to be over here at the most bottom vertex, right? And that's when the real, there should be calibrated a bit more closely to the 3. So let me just change that quick actually. Actually, a good point. Okay, so real z is equal to 3, okay, bottom vertex, and we don't know what I is, right, so what the imaginary value is, imz in this instance. So what I'm going to say is let z equal 3 plus ib, okay, because we don't know what the imaginary value is yet, so we can say that arg of 3 plus ib minus, okay, 1 minus 2i, okay, because we're accounting for the 1 plus 2i section here, right, here, and that's going to equal negative pi over 3, okay. So now we just have to get this all together. So then arg of 2 plus I b minus 2 is equal to negative pi over 3, right? Which tells us what? That tan of negative pi over 3 is equal to b minus 2 over 2, right? And if we work that out on our calculator, we're then going to get a value of negative root 3. Okay, so what does that tell us? Well, b then is going to equal 2 minus 2 root 3. Okay, so we know what b is, therefore z is going to equal 3 plus I, 2 minus 2 root 3. Okay, therefore the arg z is equal to arctan 2 minus 2 root 3 over 3, which equals, if we work that out, the calculator, that gives us negative 0.54 radians. Okay, done.